Following on from the previous video, we got to this stage here where we managed to work out the angle. We managed to work out the angle to be AT over B. I've just enlarged this. So we are currently here. We are currently here. So we've got our circle. This is our circle here. We moved it across by this much. So we moved it across by this much, and then we moved it up by this amount. We moved it up by this amount. Now that we've got the angle, we can input this into this thing here. We don't need to touch this because this is telling us to move it across by this amount. It has nothing to do with our angle. It has nothing to do with our angle. Same as this. We move this up by this amount. We don't need to touch this because this is not altering the angle. We are talking about the angle here. So we should be altering this bit and this bit. So leave this alone because this is referring to move it across by this much of an amount, and then leave this alone because we are moving it up by this much of an amount. It has nothing to do with our angle. So we need to put this into here, and we need to put this into here. So currently, when you draw a circle, if you add an angle, it actually moves. It's defaulted to move in this direction. But because as the circle rotates, it actually moves around in a clockwise direction. So we need to stick a minus in front of it to get it to move. Well, normally it's defaulted as going anti-clockwise. If you want it to move clockwise, then stick a minus in there. So now we need to put this into here. We need to put it into here, and we need to put this into here. So let's try and implement it. So looking at our particle, so you need to change this to A. Instead of T, it will be C. So hang on. So instead of this T here, it will be C. So we need to put minus AC over B. We need to put this into here, and then into here as well. So that would be AC over B, and it's a minus. So hang on. So that would be AC over what? Over B, and it would be a minus. So hang on. It will be a minus. Stick a minus in there to get it to spin clockwise. And then same with this one here. Bracket AC over B, and then stick a minus in there. Hang on, and then stick a minus in there, and then press play. It's looking okay, but it's not quite right. It's not quite right because it may look right to the naked eye, but technically it's not right because, hang on, because of this. We've worked out the angle. We've worked out this angle. Let's just imagine it's 37 degrees, not radians, degrees. Let's just imagine this is 37 degrees. When you say add this much of an angle into here, add this much of an angle into there, what it's doing, what Desmos is doing, is that it's defaulted to be here. So when you minus 37, it's defaulted to be here, and then it will add this 37 degrees here, and then it will display the particle right here. In fact, it should display it somewhere over here. It would display it. Let's start again. Let's just imagine it's 37 degrees. It's defaulted as this, so it will add 37 degrees. Let's just say it's somewhere around here. But the point is, the particle should be right here. It should be right here because this angle here, this angle here is 37. But the way, if you just simply put this into here, it will do this. Desmos will do this horizontal line, and then it will display 37 to be somewhere around here. You need to move it back by this amount of an angle. The point here is that currently, if you add 37, it will display it here. But you need to take away this amount of an angle, which turns out to be the same as this angle here. The next question is, what is this angle here? Well, we need to get 37, whatever this is, take away this angle here. The point I'm trying to make is that we need to get this AC over B, take away this much of an angle. Take away. Well, it turns out that this angle here is T, because you've got two parallel lines here, and then you've got one straight line going through two parallel lines. So this angle here must be the same as this. So this is T. The point I'm trying to make here is that we need to do this. Stick a minus in there to get it to spin clockwise, and then we need to take this angle into account. Remember, when it comes to angles, this will be negative. If you want to go the other way, it will be add. So we need to add T. Add T. In our case, it's C. And then now we need to put this into here, and into where? Into here. Okay, so we need to do this and then plus C, because we've got to take this angle into account. So let's implement it. So going back to this, we need to add C, and then let me think, and then add, and then add C, and then it will be right, because if we now make this circle to be if we make the radius to be 8 and the radius of the small circle to be 2, then we know that the circumference of the big circle will be precisely 4 times the circumference of the small circle, meaning it will give us this path here. Okay, so let's check it. So now if we make the radius A to be 8, bear with me, and then B to be 2. Okay, so now we need to hang on, let me make it smaller. So now we need to keep track of the path. So because we want to follow the particle, let's copy and paste the particle. Copy and paste the particle. Control C and then Control V, and then change all the C's to T, because T is reserved within Desmos, and it will scan through the whole system. So hang on, change all the C's to T, and then 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 T. Okay, it's following it, but we need to tell Desmos to range from 0. Instead of doing 2 pi, I'm going to get it to spin around, I don't know, let's say 5 times, so that would be 10 pi, 10 pi. So now it's spinning around 10 times. So now if we vary the radius of the small circle, it will change accordingly. If we make this circle to be really small, it will look something like this. Well, you can play about with it. I'm going to leave the link to this graph, and then you can vary the radius, and then you can vary the radius of the big circle, and so on. Okay, play about in the link below in the description. Okay.